as I have told you in my previous module that we will talk about later on about the impeller choice, because in agitation system impeller is a very critical, because the main object of agitation system is the mixing, that how mixing, we can say that how the good mixing can be achieved. So what are the negative effect during this mixing? So that is only depend upon the type of the impeller. So agitators on the base of the impellers or on the base of their working is classified into two main categories. One is radial flow category and other is axial flow category. So as concerned the radial flow mixing, that is only when the liquid flow from the impeller is initially directed toward the wall of the reactor. Mean when there is the movement of the impeller, the fermentation media first pushed toward the wall of the fermenter, toward the parallel to the radius of the fermenter. That's why that is known as radial flow. But as concerned the axial flow, that the medium and the impeller push the medium to the bottom with the parallel to the axis, but the movement is toward the bottom. So that is the axial, mean on the main axis, but as case of the radial, then there is this kind of flow, but in that case that is on the bottom. So the radial flow impellers are primarily used for gas liquid contacting, but as concerned the axial flow impellers provide more gentle but efficient mixing. We will talk about details while talking about with the graphical representation about the radial flow as well as the axial flow. Here you can see that in this slide that these are the different radial flow impellers. This is known as, you can see that Rushton turbine, as we have seen in our previous module when we are observing one diagram. So here these are the 4 blade and this the 6 blade, and this is having a flat bladed impellers. These are different type of radial flow impellers and their shape and the blades. So impellers are basically the associated with the blades. Sometimes there are 4 blades, sometimes there are 6 blades. So the number of blades is also having the part of the impeller system. So here in this slide you can see when there is a radial impellers or a radial flow, that what is the direction of the medium while the impellers are agitating. So you can easily see that as I have already told you, in case the media is pushed toward the periphery, just parallel to the radius of the fermenter. So with the radial flow impeller, the liquid is pushed toward the wall of the tank, that is along the radius of the fermenter. So the radial flow mixing is not an efficient as axial flow. We will talk about in detail about the axial flow, but as in comparison, axial flow considered to be more efficient, but radial flow has their own positive factors. As concerned the radial flow impellers, much higher input of energy because there is a more pushing. So that's more energy. That's why there is a more energy consumption in the radial flow. But there is a positivity in that. So as we say that the radial flow are not more efficient and having more consumption of the energy. On the other hand, the radial flow impellers are designed to generate high shear conditions, because when there is a high shear, then there is a breakage of the air bubbles. So having a good distribution of the air bubbles into the fermenter vessels. in this slide you can see easily that what happens when there is a radial flow impellers move. What happens when there is a chance of collision between the air bubbles, then there is a more chance of you see separation or cutting of those air bubbles. So in case of the radial impellers, the bubble size reduced to a maximum minor height. So that's why the radial impellers are mostly used when we talk about having a high shear effect condition in fermentation vessel.